Today we're looking at area of a triangle, and we're looking at extension questions using trigonometry to solve some problems that we may be faced with in the National 5 course. Extension questions here, and what I'd expect that before you look at the extension questions, if you can look at the basics of using the formula for the area of a triangle and working backwards, if you work backwards, knowing the area, using the formula and rearranging that formula, because rearranging equations is something that one of the skills that you should have learned at this stage as well. And what we're actually doing is we're looking at some polynomials, and in this case here we're looking at a hexagon to try to work out some information that we're asked for from here. Right, so what I'd like you to do is, if you can, just freeze the video and try the questions yourself. I'll show you the answer as soon as you've completed that. Okay, so here we go. Let's start with this question here. Right, a regular hexagon has been drawn inside the circle with a radius of 19 centimetres. And all we're doing here is we're going to calculate the area of the hexagon. Right, so let me just look at what I'm going to do first of all. So first of all, I'm thinking about looking at a triangle and working out the area of the triangle. I'm not going to go straight and try and work out the area of the hexagon straight away, but what I'll do is get the area of that red triangle first of all, which should help me. Right, so I need an angle, and the angle that I need is this angle that's sitting in here. At the moment I don't have that, but an easy way to work that out is I know that a full turn there is going to be 360 degrees. So the angle in the triangle, I'll just call it a triangle, is going to be equal to 360 degrees, and we'll just divide that by 6. I've got 6 equal triangles in there. So that's going to be, dividing that by 6 gives me 60 degrees. Okay, good. So that gives me some more information that I can work with. So there I've got the angle. I've got 2 sides either side of the angle that I'm given. I can work out the area of that red triangle there. And what I'll do is, once I get that, multiply it by 6, and that should give me the area of the hexagon. Let's go ahead and start that. So looking at my formula list, I'll find that the area of a triangle is going to be equal to a half AB sine C. Okay? Right, AB, let me label this triangle up. So I want to label this part here as C, I'll label this as A, this one is B. I'll label the sides across from each of them, so that's C, this one here will be A, this one here will be B, and from there I'm just going to plug the information that I've got here into the formula. Right, so I've got a half, and that's going to be times A, which is 19, times B, which is 19, times C, sine C, and that's going to be 60. What I'll do is I'll just go to my calculator. From the calculator we'll just go for, so we'll go for 0.5 times 19 times 19 times the sine of 60. And that should equal 156.317. Okay, and from there what I'm going to do is I'm going to multiply that by 6, because the area of the hexagon is going to be equal to the area of the triangle. I'm going to multiply that by 6. Okay, so keeping that number in my calculator just now, and I'll just multiply that by 6, and that should give me 937.9055, and more characters from there. I'm going to answer it to 4 significant figures, 1, 2, 3 and 4 significant. Cutting the number there gives me 937.9. It's centimetres I'm working in, centimetres squared, and that was 4 significant figures. Okay, right, so that's the first one done. What we're going to do is we're going to do a few others using different polygons. We'll be using pentagons and an octagon, etc. I'd like you to try them before I do them. We're going to do some with calculator, some with non-calculator that I think are at the top end of the work that we've got. If you can do them, then we're looking really good. Right, let's go ahead and see this one here. Okay, So go ahead and complete this one here. Right, again it's a regular hexagon. It's been drawn inside the circle with a radius of 35. So the same as I did in the first one, I'm just going to copy that out. Okay, so what we're going for is a triangle. So I don't have a triangle made up now, but I can make it up quite simply. So I'll go from there to there. So there to there. There's my triangle getting made, and this one here. Okay, so if that's 35, I know that this side here is also going to be 35. And what I know is that the angle in the triangle is going to be equal to 360 divided by 6, because it's a 6-sided shape and it's a regular shape, and that's going to give me 60 degrees. Okay, so 60 degrees in there. So it's the same as the previous one, but just to give you a bit of practice on this one. Right, so let's start with the area being equal to a half AB sine C. I can label my triangle up, so I can call this one C here, call that A and call that B, and go ahead and substitute my values in. So a half times A, which is 35, times B, 35, times sine of the 60 degrees. Just put that into the calculator. Remember, that's the area of the triangle only that we're working out here. So in the calculator, I've got 0.5. I'll go for 0.5 times 35 times 35 times the sine of 60, close the bracket, boink, and that should be 530.44, and we've got some more characters there. I'm just going to leave that in the calculator at the moment. So I know that the area of the hexagon is made up of 6 of these triangles, so it's going to be the area of the triangle. I'm going to multiply that by 6, which should give me an answer of, let's see, times it by 6, that equals 3182.64, and more characters on that one there. So what I'll do there is I'll round that to 4 significant figures. So my 4 significant figures are cutting off here, so that's going to be 318. The 6 is going to round the 2 up to 3, and that's going to be in centimetres squared. And that's going to be the final answer. That's 2 4 significant figures. Okay, let's change it a bit. Let's have a look at a different polynomial. What we'll do is we'll look at this one here. So, regular pentagon has been drawn inside the circle with radius 11.3. Calculate the area of the pentagon. Calculate the question again, so go ahead and do this one. Right, just the same thing. I'm going to make up a triangle. Triangle here, a wee bit kind of larger degree that I've got in there, but I'll be able to work that out just shortly. There we go. Right then, so if that's 11.3, this one must be 11.3 also, and I'll work out the angle in the triangle for the triangle. So what I'm going to do is I'm going to divide 360, which is a full turn. I'll divide that by 1, 2, 3, 4, 5. It's a pentagon, 5-sided shape. That should give me 72 degrees. I'll work out the area of that triangle first, using the formula from the formula list. And what we'll go for is, we know that that's 60 degrees in there. So that's going to be a half times 11.3 times 11.3 times sine 60. Whoa, there we go, that's a 72 in there, isn't it? 72 degrees, because I calculated that there, so I was on the hexagon again. So 72 degrees, getting that changed. Bump. Right, and then what we'll do is we'll put that into the calculator. I'm just rushing ahead of myself a wee bit. So 0.5 times 11.3 times 11.3 times the sine of 72. That's the angle that we've got in here, and we know the sides either side of it. So that should give me 60.7202, and we've got more characters there as well, okay? That's going to be in centimetres squared. I know that the area of a pentagon, so it's the area of a pentagon this time. Okay, it's going to be equal to the area of the triangle. And we're going to multiply that by, well, we've got 5 triangles in there, so multiply by 5 this time, not 6 as we did with the hexagon. So same number in the calculator, times it by 5, that should give me 30.5 03.601, more characters, 4 significant figures I'm after, cutting the number there, 303.6 to 4 significant figures, and that would be the answer for the Pentagon. Right then, so let's move on to another shape, right? So different shape, you try this one, see how you get on with that. What we'll do is a non-calculator question after this one, so have a quick go at this and see how you get on. Right, so I'm going to do the same type of calculation. It's a polygon again, so I'm going to just do the same type of work. So I'm going to draw a triangle in. So it's a smaller looking triangle, a thinner looking triangle, which it should be. There we go, there's a red triangle getting drawn in there. Right, from this I can see that if that's 15 degrees there, this one here must be 15 centimetres there. What we've got in there, I need to calculate this angle that's in here. So let's go and do that. So what we've got is the area of the triangle. It's going to be equal to. So the area of the triangle, I'll work that out in a sec. I'll need to work out that angle. So the angle in the triangle is going to be equal to 360 divided by how many sides it has. So it's a regular decagon and it tells me it's a 10-sided polygon. So let's divide that by 10 and that should give me 36 degrees. So in there, that's 36 degrees. Right, so formula from the formula sheet, okay, and just substitute our values in. So A will be 15, B is 15, and sine C 36 degrees. What we'll do in the calculator, we'll just multiply that out. So what we've got here is we've got 0.5 multiplied by 15 times by the sine of 36 degrees. That's going to be equal to 66.1258. So 66.1258, and the area of the decagon is going to be equal to, it's the area of the triangle, and we'll multiply that by 10. It's a 10-sided shape and we would have 10 triangles all the way around in this polygon. Okay, so that's going to give me 1.258, and what we'll do is we'll round that to 4 significant figures, which should be cutting the number there, the 5 rounding the 2 up to 3, so that'll be 661.3, so squared, that's 2, 4 significant figures. Okay, we'll move on next to a non-calculator question. And the non-calculator question that we've got here is about a parallelogram. Now this is quite a common type of question that you could be asked. Parallelograms feature quite a bit in this type of work. And quite often we're given the answer to sine of a certain degree. So sine of 30 degrees is equal to a half, or 0.5. So what I'll be doing is I'll be using that information that I've been given in the formula. So a parallelogram has dimensions shown. So what I know is I've got an angle and I've got the 2 sides beside it, and I can use the triangle calculation. It's not a triangle though, so what I'm going to do is I'm going to cut this across here. If I cut the parallelogram across from here, what I've got is I've got 2 congruent triangles. They're both the same size. Okay, and both the same area. So I'll work out one of them, multiply it by 2. Right then, so remember it's a non-calculator question, so let's go ahead and start that off. So looking at the area of the triangle, I'm going to use the formula a half AB sine C. Okay, so I've got a half times A, which is going to be 8 times 5 times sine of the angle that I've got there. Now what I'm going to do here is I'm going to use, instead of sine 30 and instead of using my calculator, what I'll do is I'll just use what I've been given. So that allows it to be a non-calculator question, and that allows us to go ahead and complete this question here. So I've got half of, I multiply them together, I've got 40, and that's going to be times another half, so that'll be 0.5. Right, so half of 40 is 20, half of 20 is 10, so that's going to be 10 centimetres squared for the area of the triangle. So for the area of the parallelogram, well, that's going to be equal to the area of the triangle times by 2 triangles. So it's going to be 10 times 2, which gives me 20 centimetres squared for that one there. Okay, let's move on to the next question, which will give you a chance to try some of the things that you've learned so far. Right, so just increasing in difficulty slightly. Okay, what we've got here is, it's another parallelogram, so you know how to solve that one. The dimensions are shown in the diagram, so I've got 7 here, 60 is the angle. Well, I've got some surds, so I know I'm going to be into some surds work here, and I've been given the sine of 60 as a surd as well, so I'm going to have to be using that to calculate the values out. So try your best not to use your calculator for this question. The work here is a combination of the area of the triangle, the trigonometry, and surd calculations. Okay, so the top end question I would expect, so let's have a look. So like I did before, so we know that a parallelogram is made up of 2 congruent triangles. So I'm going to start using this triangle first of all. Let's go for the area of the triangle. So the area is going to be equal to, we've got half AB sine C. Right then, let's see what we've got. So I'm going to go for a half of 7 times the side, which is 2 root 3, times the sine of 60 degrees. And remember what we've got, sine of 60, what we're given is this part here. So I'm going to replace sine of 60 degrees with root 3 over 2. So it's half of 7 times 2 root 3 times root 3 over 2, right? So what I'll do is I'll multiply the top line across the way. Okay, so what I've got in the top line will be, I've got 1 times 7, okay, so that'll be 7 times 2 root 3 will give me 14 root 3, so can I just do that one first? And then I've still got a times root 3 at the end there. On the bottom line, what I'd have is, on the denominator, it will be 2 times 1 times 1 times 2 will give me 4 on the bottom. Right, so I know that from multiplying surds, root 3 times root 3 will equal to root 9, and the square root of 9 is 3. So what I have up here, 14 times 3 all over 4. When I multiply this out, so 14 times 3 will give me 42. 42 all over 4, and what that will be if I divide that out, that should give me 10.5 centimetres squared. Remember, that's for the triangle. Now, for the parallelogram, I'm just going to have to double that. So the area of the parallelogram is going to be equal to the area of the triangle times 2. And we've got 10.5 times 2 will give me 21 centimetres squared. So this one here, quite a top line question, obviously with the surd multiplication coming in there and simplifying down some kind of reasonably complex fractions from there. Okay, so let's move on. Right, so the next one is what we're going to be looking at is we're going to be working backwards, which are quite complex problems. Okay, so we've got a polygon. It's a pentagon here. It's a regular pentagon, and we know the area of the pentagon. And we have to calculate that length that's here, this length x. Okay, quite a tough question, this one. If you think you can have a go at it, have a try and see how you do. Okay, you can stop the video partway through the solution and try to complete it yourself. Let's go ahead and we'll look at what we're going to do with this one. Right, so the Pentagon, I've got an area of that. So what I'm seeing in there, I can see another triangle that I could maybe make up here. So if I make up the triangle from here to here, okay, from here to here, and from here to here, right, so I've got a triangle. What I'm going to do with this triangle, I know that this side here, although I don't know it, I know it's x centimetres because it's the same as that one there, it's the radius of that circle, and I need to know the angle that's going to be in there. Okay, so the angle in the triangle is going to be equal to 360 divided by 5, and that's going to give me 72 degrees. Okay, it's a calculator question, this one here, and let's go ahead and we'll try and solve that one there. Right, because I know that the area of the Pentagon is 237.75, the area of the triangle will equal to the area of the Pentagon divided by 5, because there's 5 like triangles in there. So area of the Pentagon is going to be 237.75 divided by 5, and just file that into my calculator. Okay, so 237.75 divided by 5 should give me 47.55 centimetres squared. And remember, that's the area of the triangle. Right, so with the area of the triangle, what I can do is I can start working backwards. So if I want to find out what the sides are, I know the angle, so let's go for the formula. Area of the triangle. Okay, just from the formula sheet, half AB sine C. I know the area now, it's 47.55. It's equal to a half times, right, so A and B. So if I was calling this C here, calling this A, B at this side, so A will be X centimetres and B will also be X centimetres, and I don't really need to know C in this case here. Right, so that's going to be times X, okay, and then what we're doing is we're multiplying that by sine of the angle, which is 72 degrees. Right, so to try and move this around for myself, so what I'm going to do is I'm going to bring a half and the sine 72 over to the left hand side of the equation, okay? So I've got 47.55. What I'm going to do is I'm going to divide that by 0.5 times the sine of 72 degrees. Okay, put it in a bracket so I don't lose it. On this side here, I've got x times x, which will tell me it's x squared. Right then, so let's go and work this part out here. I'm going to be doing my answer to one significant figure, so I'll be working that through. So 47.55, I'll divide that by 0.5 times sine of 72 degrees, and that equals, so that's going to be x squared is going to be equal to 99.994 and some more from there. And what I'll do is I'll take the square root of that. So I'm going to leave that answer in my calculator, and all I'm going to do is I'm going to square root the number above, 99.994 and so on. So x is going to be equal to, so square root of the answer gives me 9.9997 and so on. So what I've got here is I've got the size of the radius of that circle, and if I'm going to give it to one significant figure, so I'm going to cut the number there, that 9 is going to round that 9 up to 10, so that's going to be 10 centimetres. Okay, and that's a final answer. Complex question. I've got some more of these for you to try, and what I'd like to do is I'd like to stop the video there, and I've got 4 other questions that are quite complex like that, so I'm going to split this into another video and that's us closing this one just now. So good luck with these extension questions. They are tough, but if you just keep with it, you'll be able to solve these questions. Good luck.